I'm going to start with you, Ali, because the Drive for Innovation is about innovation, but we do talk a lot about automotive electronics, obviously because of the Bolt. We spend a lot of time in Michigan, in Detroit. And we talk about the car. We tore down another Bolt a couple of weeks ago, and we're reporting on that on the driveforoinnovation.com. So we talk about that. But we haven't had a chance to talk to or had access to somebody like yourselves to talk about where the car network is going. So at lunch you were talking about the glories of Ethernet, and I want to hear a little bit about how you guys are implementing that and why that's important.
Sure. So Ethernet is a very established technology. We've been shipping Ethernet in the IT industry, service provider, data centers for many years, and most of the engineers in this room are the pioneers on that field, and we've been contributing to that a lot through the last 20 years or even more. What makes it very interesting at this time for automotive industry, we believe that Ethernet has come to a point that has everything that the next generation automotive networking requires and needs. There is today, if you look at a typical car, there are multiple networks inside that car. There are networks that for camera systems. There are networks for your infotainment traffic, whether you're playing your music or your children are watching a movie on the rear seat entertainment unit, or whether you have a diagnostic unit, some technician is running some tests on your car, or you're running some control signals, on your windows or in your brake system. Many different applications that they're running over some sort of wire inside the car. Some of these are coax, some of them are twisted pair, some of them are optical. So it's basically a lot of different networks. So what we found in Broadcom a couple of years ago, that there is room for a new innovative technology to come and enable these next generation services and such as advanced driver assist system, infotainment, and potentially a lot more running over an Ethernet, very low cost Ethernet network. And soon we realized that we are up to something good here, because as you start looking into the cost elements inside the car, one of the major cost drivers inside the car is the wiring system in the car. In fact, the studies shows that after the engine, the cable harness is probably the second. It depends. Some people, they say the third. Some people say the second. But it's pretty much up there from weight and the cost inside the car. What are the drivers today in automotive industry? Bring the cost down, bring the weight down. European Union, for example, they're putting some mandates that the amount of CO2 emission should be limited. Otherwise, the car manufacturers have to pay a penalty if they exceed that limit. That's something I like to have in the USA as well, right? I mean, that's less pollution. So how do we contribute to enabling that is to come with a very low cost and low weight technology. So Ethernet, when you go layer 2 and above, very established for data center service providers. The PHY transceiver technology is where you hit the wire. And that's where we put an innovation, a technology we introduced to the market called broader reach technology that allow you to run Ethernet traffic. Let me show you this over this type of cabling. This is FlexRay type of cabling. Automotive industry is very familiar with it. And if you look at this very thin, twisted pair, unshielded cable, and the task that we were facing and Broadcom engineers solved that was running 100 megabit per second traffic over this, at the same time meet the very stringent EMI, EMC requirements of automotive industry. If you look at, for example, a typical camera system today that they're using digital technology, people are using this type of cabling. This is LVDS cable. Compare these two type of cable, way heavier, a lot more expensive shielded cable, bulky connectors, And we came with a technology that allows you to run Ethernet over this type of thin wires. That's cost saving and weight saving. We've done studies that shows that you could save up to about 80% on the cost and 30% on the weight of a typical surround view and camera systems inside the car compared to LVDS. So that's on the camera system. And by the way, ADAS, Advanced Drive Assist System, is one of the fastest growing sector of the market. Now, on the other side, on infotainment, you want to run audio and video. In the last couple of years, IEEE has been working on a new technology called Ethernet AVB, which is basically designed to run audio and video traffic inside a network, do bandwidth reservation, tight control over delay, all the things that an audio and video traffic need today. So we found a very exciting opportunity here that you could reduce the weight and cost on the media. You could enable an Ethernet solution to run audio and video traffic. And as such, we came with a portfolio of products with the PHYs and switches that enable this connectivity, Ethernet-based connectivity inside the car, and allow our automotive customers to bring them to the market. And we have been getting good traction with our customers so far.
Before we go over to Richard, is this the kind of solution at the kind of price point that might sort of break through the traditional automotive electronics barrier, which is the expensive stuff starts in BMW and Mercedes, and then as we cost reduce it, it comes down to mainstream cars? Or are we going to continue that pattern with this?
No, absolutely. Very good question. Actually, one of our main goals was to drive the cost down on the connectivity, that this type of technologies are not only for the luxury provider. Today, a lot of advanced driver assist systems or when you buy one camera only, they're on the luxury cars. But that's the beauty of our technology, to allow you to have a very low cost alternative for the connectivity. And as the volume starts to go, they could leverage the Ethernet-based economy of scale, so the cost of connectivity becomes lower. And we would see that this technology could get into the medium and someday also on the low-end cars with this. There are some mandates, some regulations that are going to mandate most of the cars to have, at least in the North America, to have backup cameras at some point. And we believe this technology is going to help them to have a low-cost alternative to enable that.
So let's go from the wired world to the wireless world. Because Richard, at lunch we were talking about down the road, various kinds of wireless technologies are going to enable us to do things more than just talk on our cell phone hands-free.
That's absolutely correct. And we're basically going down a path that what you're using your phone for, and for a personal device or within your home or so forth, is going to happen within your car as well, using the wireless technology very similar to what's in your phone. If you step back, if you look at wireless technology in the telematic infotainment center, it did start with Bluetooth. And it started with basically the ability to use a headset, a Bluetooth headset, that people were using with their Bluetooth phones, and being able to translate that into the automobile by having a hands-free kit in the car. Now that was driven even further by legislation, driving hands-free requirements throughout the United States, throughout Europe, which really drove the proliferation of Bluetooth in the automobile to where it's about 70% of new US vehicles right now, and probably pushing towards 50% worldwide with Bluetooth attached to automobiles. Huge amount of Bluetooth devices being shipped in automobiles. Well, now you're seeing another shift. People have gotten used to hands-free kits. People are using A2DP to be able to play music off their iPhone into their automobile with a Bluetooth system. Well, now if you look at the mobile phone industry, there's been almost 100% attach of wireless LAN within the smartphone. The smartphone revolution is taking off. And many of these applications using wireless LAN, you now want to bring into the automobile. These could be some things as simple as much faster data transfer, the ability to use the phone as a modem and be able to connect up as an access point to your automobile, or maybe an OnStar system where the automobile's got a modem and you're connecting your phone up to that over wireless LAN. Many applications that we're doing today in the Starbucks and so forth. But you're also seeing new applications come out in the home media environment where you want to be able to take your mobile phone or your tablet that that's already got some video content on it from iTunes or whatever, and display it up on your TV screen. Or you're playing a game on your tablet and you want to be able to show it up on your 52-inch Samsung TV. That technology is also coming in the mobile phone, and it will really be powered by the 5G technology, the 5G wireless that we're bringing to market right now. 802.11ac is the 5th generation of wireless LAN technology. It is the technology that's really required to have a true Wi-Fi display experience where you eliminate latency and you have a very good user experience at high resolution on your display, whether it's from your phone or your tablet going to your TV, or your phone or your tablet going to your infotainment center in your car. And the big application we see, or the really cool application, is personalization of your car. You get into your car, you got your iPhone. All of a sudden, your display on your iPhone is on your touch display. So all the icons and everything that you're used to seeing, whether your playlists or everything, your contacts are right there, mirrored exactly. It's display mirroring exactly like it's on your iPhone. Let's say your spouse gets in the car. Your spouse is an Android user. They're driving the car. All of a sudden, their display pops up, and they see an Android display, or they've got a Nokia Lumina phone, and they see the Windows tiles pops up. Or you get in a rental car, and whatever phone you have is the display that you're seeing. It personalizes the vehicle display. Actually makes for a better user experience and probably a safer user experience because then you know what that display looks like from time to time. So many applications you're seeing within the home and you're seeing within personal devices are going to be enabled using wireless technology, Bluetooth and wireless LAN. Next steps are going to be NFC technologies driving into the phone, so you're going to see NFC go into cars for easy pairing, simplified pairing devices. Bluetooth Low Energy is going into phones. So you can see Bluetooth Low Energy being used potentially as your remote, so you can use whether your key fob could be Bluetooth Low Energy or your phone could remote start and remote unlock your vehicle as well. So you're using all these technologies and basing them off technology that we've brought into the mobile phone world, and now in a very inexpensive manner, again, bringing it into the car. But there are some other secondary benefits in industry using. So if you look at Ford Sync, Ford is probably leading right now as far as the wireless connectivity from the user experience. They are our first new customer for our own Bluetooth wireless LAN combo devices, and they're taking it beyond just the infotainment experience. They're actually using it in a manufacturing standpoint. So instead of stopping the vehicle and plugging in a cable and uploading software into the vehicle, while the car is moving down the production line, they're actually loading in all the software on the production floor using wireless LAN. Or when another module gets put in somewhere else in the production line, they have to stop the car to load software. The software gets loaded up automatically wirelessly. Halfway down the production, somebody sends a change in software. Oh no, we had a new software release. Very easy. Don't have to stop the car. You can upload the new software right there. Take that to the dealership. You go into the dealership. The dealer can upload new software wirelessly, or you go into your service station, and instead of the mechanic fishing around for the right connector to the plug from the GM car or the BMW or the Ford, he just does it wirelessly, and all of a sudden all the engine diagnostics pours into his box of a wireless LAN meter. The manuals for the car, everything is stored in the vehicle's memory, and you come to him seamlessly without having to pull out a connector. That's the next stage, and then the stages after that. If you look at what's happening today, they just issued the first driver's license for driverless cars in the state of Nevada, the first license plates, and they're about to do it in Arizona as well. The Ethernet technology that we're developing enables this car to become a sensor observatory, to be able to have radars and cameras to see what all the vehicles around them are doing and have great visual and data input from a sensory standpoint, driven over Ethernet. The wireless will enable car-to-car communication. So when you see the person in front of you, before the radar picks up the inertial change in the car that he's slowing down, your car can actually detect that you put your foot on the brake. That can be sent over wireless LAN or Bluetooth to the vehicle behind them, so you have millisecond improvement in the ability of that car to respond to the environment around it. When you get into those environments, this next generation, that's evolutionary, or the big E, where cars can drive themselves, all this technology is going to tie together to make that happen.
I had a question for you on the whole, the communications infrastructure that the automotive manufacturers have. GM has OnStar, Ford has Sync. How is that, and they're trying to create maybe their own walled gardens the way Apple and Android have. How does that work when everything is controlled by your phone in this world? Is there going to be some contention between those two worlds, not technologically, but in a business
I don't see the walled gardens within that particular industry at this point in time within telematics. Because the telematics are served, the OEMs drive it, but it's also served by a group of companies called Tier 1s. And these Tier 1s, whether they're Bosch, Harman, Conti, LG, serve many manufacturers, and they're taking very similar technologies to many manufacturers. Similarly, the operating system manufacturers, makers such as Microsoft or Android is going to be driving things, are going to drive very similar user experiences across automotive brands and automotive manufacturers. It's more about, from their perspective, of having an enhanced user experience to make their car friendly, rather than creating something completely proprietary that walls off from everybody else. So I see, a lot of synergy between the automakers. Now, they're doing some things different. Obviously, GM has an OnStar plus an infotainment center that they are able to connect back and forth through, which is a little different from Ford Sync, which being a single type of point. But I don't see that industry building walls between themselves. It's not so much their nature as you may find in other industries we serve.
So maybe this is a question for Tim, or maybe it's a question for you. I'll let you guys duke it out. But we know that, as you pointed out in your earlier answer, the technology can make the cars a lot safer in and of themselves, but user adoption is a completely different thing. We fly in planes now that are fly-by-wire. But when you're trying to convince the driving public to let go and let God, if you will, is that going to take a long time, do you think? Or is it going to take
Tim, you want to park the car on this one?
sooner than what we anticipate?
Right, so you're right. The automotive the development cycle is about 5 to 7 years. It's getting shorter and shorter, but still that long, right? So if you go out and buy your the brand new car out of dealership, that was designed 5 years ago. Okay? The typical car has 40 to 60 microcontrollers per car, even if you don't see any of these computers, right? But anyway, back to your question. Today you could go out and buy high-end European cars or high-end Japanese cars, actually also one Detroit cars, where you would be completely hands-free in highway driving today. You could buy one today, right? It's just a small option. And what they do is OEMs slowly feel comfortable with certain type of features, and over time, when they believe that it's mature enough and reliable enough, including legal issues and liability issues, then they will enable those type of features out to the market. But that doesn't mean that the development is not going on now. So if you could imagine, GM and Volkswagen, they both publicly vowed to have driver optional cars by 2020. Production worthy, meaning the production aspect, the technology aspect, all those are mitigated and worked out, and if the regulation allows it, they could produce it. That's what they vowed publicly, 2020. That means they must be working on, right, because they have to disclose it, but they must be working on type of features and functions that would enable that by 2020 now, and as they feel comfortable enough on all of these maturity metrics, they will enable that slowly. And as part of the answer, the airplanes have triple, quadruple their redundancies, and those type of things are also in cars. So some of the engine controls have fully redundant, triple redundant processors that are going through mission critical computations. And those as those get proven out, matured, then they get optimized. Either they get optimized from the integration, which is exactly what Broadcom is good at, or it gets integrated, it gets mitigated through system redundancies and fault tolerance. One fails, the other one takes over. Network allows you to do that. So all those venues are being explored today, if you could imagine. So again, 2020 is what we're trying to get to. We are into 2012, so you could see a lot of activity must be going on now.
So quickly on this also from you, I think your question was also from a driver's standpoint, how comfortable that a driver would be actually in terms of trusting the system to fly-by-wire or drive-by-wire. So I think the automotive industry, my sense is the automotive industry is addressing this kind of in two different ways. They're starting first right now with very passive controls for safety systems. If you're starting to veer out of your lane, they have lane departure warnings. You'll hear a beep and it'll get you, comfortable with the fact that the car is guiding you to come back to, a safe driving mode. The automotive industry, as Yang mentioned, though, is moving from a passive safety system towards more of an active safety system, which eventually we can see where if you're starting to depart from your lane, the actual system will actually take the system away from you and will move you back into a safe, a safe driving zone. So I think from a customer perspective or a user perspective, to get customers comfortable with the entire, eventually moving to self-drive or autonomous vehicle, driving. It starts with a passive safety system, passive driving experience where you get warnings and beeps, and then moving towards a full active system where they're actually driving the car for you. They will actually actively take control away. Okay.
So I want an assessment from you guys, if you're willing to go out on a limb. This road trip's about finding innovation, and when we think about the automotive industry, we think that the most innovative automakers are the ones who sell the most expensive cars because they can afford to buy the bleeding edge technology. Are there automotive makers out there around the globe that, in your assessment, are really innovative, but not necessarily selling $50,000 cars? And why are they innovative?
Sure, I'll start with this one. So, I mean, my sense is that the entire automotive industry right now, and I think this is a recurring theme that you hear from Yang and Richard and Ali, is that the automotive industry today is just on the cusp of really making some great strides in innovating in automotive. It's a great time for automotive. If you think back, not too long ago, we were still using roll-up windows, and we didn't have rear seat entertainment systems. We didn't have camera systems. But very quickly, I mean, in today's day and age, we're moving away from analog rear view cameras to very high resolution digital rear view cameras. We're moving from just a single camera for driver assistance to a full surround view camera system with 4 different cameras. The infotainment network in your car used to be just your cassette deck. Now you have a Blu-ray player, you have a DVD player, you have multiple rear seat entertainment units. So this innovation is happening in automotive today. And it's really driving the need for, once again, the technology that I think we all talked about, innovations in Ethernet technology to be able to have high bandwidth, high performance networking in the car to be able to send audio and video and camera data reliably through the car, but at a very cost competitive price. And all of this technology and the wireless technology, the Bluetooth technology, is kind of converging together to, first and foremost, simplify next generation designs. Enabling all of these new features, but really enabling it at a price point, once again, as Ali mentioned before, that is very competitive and can be integrated into not just the high-end, high-end model manufactured cars, but also into the mid-tier and even into the low end. And so that's key. And we can see the support for this innovation and this desire to innovate and drive more technology into the automotive by the creation of what Broadcom is a partner in is the One Pair Ethernet Alliance, which BMW and numerous other automotive OEMs, tier ones, and silicon suppliers have joined together to create an ecosystem for automotive Ethernet to, once again, kind of enable this innovation in automotive.
And again, I think from a cost of the automobile standpoint, I mean, yes, luxury vehicles, it's a lot of the cabin aesthetics, the leather or wood that's used inside the cabin, obviously the engine and the drivetrain, especially the quality and performance of the engine can make a big difference. And it's the overall perception of quality, and even the nameplate that's on the car makes a huge difference. But when you look at automotive electronics and a lot of the simple features, I mean, Chrysler for years, for example, has innovated everything from door locks to seat belts, I believe. And they've never been a high-end automobile manufacturer. within what's happening within wireless LAN and Bluetooth, the first, I would say more comprehensive system has really been with Ford, and definitely with medium price type cars. GM OnStar has been quite an innovator for a number of years now, bringing telematics and modem phone technology into the car. And these were vehicles that were offered across the spectrum of the vehicle offering. Some of the differences, though, on these lower cost cars, they use these as features to upsell the car. They sell these features to increase their profit, whereas maybe in the luxury car it becomes as a standard part that's available. So I don't think it's the luxury car manufacturers versus the more economic vehicles. There's any differentiation who's driving it. It's more in how they package it and how they sell it.
Yeah, I asked that question hoping to get one of you guys to go out on the limb, but when we did the teardown of another vault in Detroit at Mngr and Associates, when we were done, they took delivery of a vehicle from Tata. That's a van. It's a family van. Now, a couple of years ago, they were contracted by Tata to do an analysis of a pickup truck. And their report basically said, this thing shouldn't be on the road. It's a terrible vehicle. This thing wheeled in the building, and it's beautiful. It's like nothing you've ever seen before, and you wouldn't expect, right? It's like you wouldn't expect Hyundai to eat Toyota's lunch in the last 10 years. And so there's a lot of interesting stuff going on out there that's being enabled by electronics.
Yeah, I wanted to add another perspective to that as well, to your question. As the electronics starts getting more and more inside the car, and that's the trend that nobody's questioning, and that's why we're excited about this, is that there's going to be a shift in the R&D, which in our opinion, by enabling low-cost connectivity, like Ethernet-based connectivity, wireless connectivity, you got to get to a point that the car OEMs do not have to carry several different R&D centers to concentrate on the hardware side, on the, I need to support Ethernet here, I need to support MOST there, I need to support LVDS there, and these are engineers, these are organizations they need to have, this is the R&D money that they need to put to support those organizations. And what we see is with this low-cost connectivity coming, and with the technologies that we bring to the market, they will have a check mark there, and where they're going to be able to put their R&D effort is on the service creation, on the new advanced services. We mentioned one or two of those areas, autonomous driving. Even before that, there's going to be a lot more lane departure warning, detecting an object. If the kid is behind your car, is going to stop. If, God forbid, you're having a heart attack while you're driving, they take the car, take you to a hospital. A lot of these innovations, and who knows, who could have thought about the Facebook effect or these things 10 years ago before they came up, right? So you make a cheap infrastructure connectivity inside the car, a low expensive connectivity inside the car, and let the innovation happens on the service layer. I would expect you see a lot of those in the next 10 years in the automotive industry. And these are not just the services that only luxury cars need to provide. How many engineers do you need to come with the new services that changes the next generation of driving? Because as Yang mentioned, you're going to have a lot of processors in the car. And Tim mentioned the connectivity inside the car, and then Richard talks about the wireless car-to-car communications. Then, when these things get established and people do not have to worry about, okay, I need to have a whole R&D to enable it, then you concentrate on the efforts on optimization of R&D and then creating new services. And this could be cars and services that you and I are not thinking about them at all. You could see them 10 years from now.
This is all fascinating stuff, but there's got to be something that terrifies you, that worries you about the next year, 2 years, whether it's more competition, finding the right skill sets coming out of school, or something. If you could each give me the thing that makes you wake up and sweat at night. Good way to end.
Well, competition is always healthy. In fact, what we've learned from automotive industry from the very first day was, well, Broadcom, thank you very much. You have a very good technology, but if you want to just play it yourself, good luck. And it made sense to us because we always believe in competing in a bigger market than having a small market to ourselves. That's the vision we really have inside Broadcom. So Tim mentioned Open Alliance, right? One Pair Ethernet Alliance. is a consortium we started with about 9 members in November. Tamara here just had a press release last week for Open Alliance that the members are more than 40 members right now. So what I believe we have a good momentum for automotive industry. What we're thinking these days is how do we get other people faster to join this new initiative, which is the right initiative for automotive internet, and having other semiconductor companies. We have a lot of them as partners, but there's still some of them that they're watching and just joining and promoting the Ethernet connectivity inside the car. And that's and we're having some good progress in some areas in the world, but we would like to make it global across the world, and that's what we're working on.
Richard, what's your big scary thing?
I think my concern, like many people on the planet, is really the global economy. And because the automotive industry is so large globally and it's so connected and tied together, that any impacts, whether in Southern Europe or North America, Asia, whatever, can be felt on a global basis. That does impact R&D dollars, which impacts the ability to implement new technologies in the product, in this case, vehicles. For our technology, it is emerging. 5G Wi-Fi is an emerging technology. It's not like we can ride the wave of existing shipments and where perhaps a reduction of R&D could help us if we were the older technology. And we've actually seen that in other industries. For us, we need the emergence of the new technologies, and we need it to be driven by robust vehicle sales and robust R&D budgets.
Tim?
My sense is my biggest concern is honestly right now the interest in automotive Ethernet, specifically the broad reach technology, has just been fantastic. As Ali mentioned, the Open Alliance, the sheer number of new members that are being adopted has just been incredible. We started the Alliance back in November, and now in May we have close to 46 different new members that have joined. So it's just the adoption and the amount of interest has just been tremendous. And I guess my biggest concern or biggest fear is that we need to continue to support and take care of all these customers and be able to really service them to the manner in which they're accustomed to, and with that we need to continue to grow. And I think that's that'll always be a challenge, but something that Broadcom, with our strong focus on execution, will continue to do well at.
Yong, you get the last word.
That's the question. So actually, I do not. I'll share the fear in a second. Let me introduce one new topic which is not fair. When you introduce Ethernet and Wi-Fi and so forth, it's well-known technology. So previously there was security and obscurity, all these proprietary technology. So it's out of fear because we know how to do this. The whole industry knows how to do this to secure the connectivity so that it works well and the way it was intended, and keep the intruders out. My biggest fear actually is I really like driving. I really like driving, right? So all these safety issues, I'm afraid that they may mandate my driving habits to be something less. And second fear is that all this technology we are helping our OEMs to adopt in a low-cost fashion, I will end up paying for it with the entire supply chain margin at the end when I go out and buy a new car.
I want to thank you guys.
Thank you so much. Yeah.